It's easy to create variables in Python. You type a equals 10 and variable a is created with value 10. Yep, it looks simple enough, but many things have happened under the hood. And in this video you learn why variables exist and how they work in Python. To understand variables, I will first show you what a computer program without variables looks like. Imagine this. You are writing a program that adds two numbers. The input comes from the keyboard. The user entered the number 4 on the keyboard and then the number 5. Your program needs to add both numbers. But to add these numbers, they need to be stored somewhere so the program can work with them. So how does this work without variables? Well, the programmer takes the value and stores it at a specific memory address. And the same happens for the second value. Since you chose these memory addresses yourself, you also have to remember them. Much like remembering where you park your car. Now, what does the programmer need to do to add the numbers? Both numbers need to be loaded into the CPU. The CPU adds the numbers, and the result is written back to a memory address. At the core of your computer, this is still happening. But you can already imagine the headaches if you have to manage memory addresses yourself. So, what is the solution? We use variables. Variables still have values and memory addresses, but they add something to it. A name. The programmer can now work with the value through its name. The memory addresses are not relevant anymore and will be managed by the programming language instead of by you. You have already learned a big advantage of variables, and that is that you don't need to think about memory addresses. Instead, you can access values by their names. And now I can show you how they work in Python. This code creates a variable with value 10. But what happens exactly when the code is executed? An object with value 10 is created. Notice that although Python is a dynamic language, the object is of type integer. This is because Python recognized a number during the assignment. The next thing that happens is that a name is created in the current local namespace, and I'll show you what that means in a minute. What's important now is that there is a reference from the name to the integer object, and the combination of it all is the variable. But the individual elements of a variable are stored at different locations. Let me show you. I create variable a and print it. And here is the result. Now I want to know where the integer object is stored in memory. I print the identity. The object address is printed. A quick warning. It can be helpful to check the ID for debugging purposes, but never ever use it for functional purposes. Not only will it change every time you execute the program again, there is also no guarantee that the identity behaves the same across Python versions. In other words, let Python deal with identities. So, when the object is stored at an address, where is the name stored? I use the dir function to print the names in the current local scope. And there it is. A is a name stored as an attribute in the module. Now, what happens when I assign A to name B? Can a name have a reference to another name? I print the names in the local scope. Two names are created. Where do they point to? I print the identities of A and B. Look at their identities. A and B point to the same object. So instead of name B pointing to name A, both names point to the object. An interesting detail is that the object actually keeps track of how many names point to it. Python needs this to be able to clean up objects when they are not used anymore. And there is another implementation detail that is very interesting here. This time I explicitly create two variables with the same value. I print their identities. What do you think? Are the identities the same? They are. When variable a was created, Python created an integer object with value 10. But when b was created, Python reused the object for optimization purposes. So, when variables are assigned, objects may be created or reused. The logic behind this mechanism can be overwhelming, and I encourage you, again, let Python deal with these details. 99.99% of the time, it is highly unlikely that you need to worry about these things. Now, there is one more thing I need to talk about. As you might know, the word variable means changeable. But since a variable is composed of a name and value, what is it exactly that can be changed? I increment a and print a and b. Notice that a and b have different values. What happened to their identities? They are different. Before changing a, both names pointed to the same object. Then a was incremented. By doing so, a new integer object was created and a was unbound from the old integer object. Finally, a was bound to the new integer object. So, why was a new object created? Was it because b was also bound to the same object? Let's test this. This time I create a single variable and print its identity. I increment a and look at the identity. It changed. And this teaches us an important lesson. The integer object is immutable. So when it is incremented, it creates a new integer object. A is unbound from the old integer object and bound to the new one. The old integer object will be cleaned up by Python automatically at some point. So a variable is mutable because its reference to an object can be changed. But it goes even further. You can even reassign an object with a different type. For developers who are used to typed languages, this seems strange, but in Python, this is perfectly good code for a simple reason. A variable name is just an identifier and has no value or type information. It is the object it is linked to that contains the value and type information. A common mistake is to assume that variables work the same across languages. Coming from C# myself, I can tell you I had a completely wrong idea of variables in Python. The same thing applies to Python's duck typing. And if you want to learn what that is, click on the screen right now and we'll see each other in the next video.